Alright, today's lesson is on similar polygons. Similar polygons are two polygons. They're similar if their corresponding angles are congruent and their corresponding sides are in proportion. Not to be confused with congruent polygons. Of course, congruent polygons, same size, same shape. Similar polygons, same shape, not the same size though. The most difficult thing about similar polygons is determining which sides are corresponding and the angles that are corresponding. Now, when you look at this example down here, it's not too difficult because the polygons are set up so that they match one another. That's not going to be the case with some of your homework. They'll go ahead and flip the shape, they'll twist it around, but they'll still be similar. So it's your job to figure out which sides are corresponding. Now, if you had two triangles that were faced in opposite directions, you're going to be looking at the angle markers. So based on this triangle, these two angles are corresponding, and these two angles are corresponding. We can determine that or assume that the third angle here is going to be corresponding because there's only 180 degrees in a triangle, so that third angle is going to have to be corresponding, therefore congruent as well. When you have problems like this in the book, what I suggest is go ahead and trace it, the first one, and actually flip the book over to trace the second one. That way you redraw it so they do correspond. Makes it a lot easier. It's not required, but without it you have to do a lot of imagination and some visualization flipping, so to speak. So I would recommend going ahead and redrawing the triangles to make it easier, or the polygons, whichever the case may be. This has to do with proportions, trying to find out what the missing side is. Now I believe this first example has a problem with it, so I'm going to pick just two of the corresponding sides and work with it that way. I believe I've made a mistake on this one, and if you do a different corresponding side, you're going to get a different answer. So there is some number problems here for this first example. That being the case, technically they're not similar triangles, but we're just, with that assumption in mind, we'll just go ahead and go with it. Now, it already states if quadrilateral EFGH and PQRS are similar, find the length QR. So the first thing we need to do is find length QR, which is right here. This side corresponds with FG. So X is going to equal that FG, 29. Now I need to find another matching corresponding side. PS and EQ are corresponding. I'm not dealing with any decimals or fractions there, so I'm going to go with those. Anytime I can avoid even a decimal, I'm just going to go with it. Now X came from this quadrilateral, so I'm going to put this value 20 underneath X. For 29, 12 is on that similar polygon, so I'm going to go with 12 here. Again, these are all in the setup. Once you have the setup down, not terribly difficult. Cross multiply, 12 times x is 12x, 20 times 19 is 380. Divide both sides by 12, and x equals 31 and 2/3. On your calculator it's going to be 31.66666. 6 repeating is just 2/3. It's easier to do that. So that's how you do the first one. Looking at example 2, Luke drew a detailed map for his class website. This map is 6 inches wide. So I'll draw a picture here. 6 inches wide, 9 inches long on a monitor. If it is 4 inches wide on a smaller monitor, what is the length? This one is actually a little bit easier than the previous one. So my corresponding sides, 4 and 6. It really doesn't matter how I have it set up, it's just so long as I'm cross multiplying the same numbers. So I'm going to put 4 on the top this time, 6 on the bottom, because those are the corresponding sides. X on the top, 9 on the bottom. I cross multiply, 4 times 9 is 36. 6x here. Divide both sides by 6, and x will equal 6. All right, at this time, go ahead and open your books to page 359. And try problems 4 through 5. I'll scratch that. 4 through 6. Go ahead and pause the movie at this time. Take a few minutes to work on the problem, and when you're ready, restart it. Okay, number 4. Tell whether the rectangles are similar and explain your reasoning. So we have 2 triangles, or 2 rectangles there. One with the dimension of 2 centimeters by 8 centimeters, the other one 14 by 4. Now, some of you may have already looked at it and it's like, well, 2 times 2 is 4 and 8 times 2 is not 14, so those aren't matching up. And that would be a good reason. If we do it mathematically just to prove it, though, we would cross multiply. So all of my information on this rectangle is going to this side of the proportion. All my information for this rectangle is going to this side of the proportion. 8 times 4 is 32. 2 times 14 is 28. So they are not similar. Number 5. They give you this triangle here. And this is what I'm talking about when retracing it or redrawing it might be helpful. There's 4 there, 6x, and let's see, we have 5 for the short side here, and 10 for the long.
Good morning, everyone. Just letting you know the Science Committee is now meeting in Ms. Van Wagner's room, room 233, right now. Again, Science Committee, please report to room 233. Thank you.
So we have to find out the value of x. So if I redrew these 2 triangles, this would be my small one, 4x and 5. And yes, this is a 3, 4, 5 triangle for those of you who already know Pythagorean theorem or Pythagorean triples. 6 and 10 here. I need to find out what x is. I don't have a value for here. Now, again, this is a Pythagorean triple. Some of you may say, well, that's 8. That's fine. Just the information's not there, so we're not going to go with that assumption yet. The information we do have is these corresponding sides. So we're going to create a proportion based on those corresponding sides. 5 over x equals 10 over 6. Cross multiply. 5 times 6 is 30. 3 times 10 is, I'm sorry, not 3. 10 times x is 10x. Divide both sides by 10, and the value will be 3. Number 6. Let's see, we have to refer to example 1 on page 358. And they want to know length of HL is. So HL is on my second pentagon, this value here. My first pentagon, not drawn to scale, but that's okay. 12, I have 5 on this side and 4 here. That's enough information right there to do this problem. I can create a proportion based off this. So 5 over 12, 4 over x, 5 times x is 5x, 12 times 4 is 48. Divide both sides by 5, and x should be 9.6 meters. Okay, homework tonight. After you get done with the quiz, page 360, 8 through 14 even, 16 through 22. Enjoy your quiz.